Hi, everyone. Thanks for joining this webinar. And please wait for a minute or so that we can start with a few additional people. And thank you in advance for your patience. So hi, everyone, again, and thank you for joining this webinar with Check Point and our strategic partner, VMware. My name is Jonathan Moreski. I am the product marketing manager for Check Point CloudGuard IaaS. And strangely enough, today I'm working from home, believe it or not. So I apologize in advance if there's any background noise. So I'm very happy to kick off this webinar about advanced security for VMware NSX with Check Point. So some housekeeping first. Please use the Q&A panel to ask your questions at any time during the session. And I'd like to introduce our experts. Stein is a senior technical PM product manager at VMware. And Chris is the cloud security architect in EMEA at Check Point. And just a couple of words. Firstly, introduction to Check Point. Stein will do a VMware NSX overview, and then Chris will spend the bulk of the presentation talking about advanced security for VMware NSX with Check Point. And we'll have 5 to 10 minutes towards the end of the webinar for questions and answers. So please, again, add your Q&A to the Q&A panel at the bottom of the screen. So some words from our sponsor. Check Point is the largest global cybersecurity company with 100,000 plus customers, 88 countries, 6,200 partners. And we invented the stateful firewall and over 25 years of technologies, very visionary and with innovation and leadership. We've been trading on the NASDAQ since 1996. In fact, our CEO, Gil Schwade, is the longest standing CEO in the whole of NASDAQ. It's something that we're very proud of. And we have over 5,200, perhaps even 5,300 employees worldwide with some of the top security and cybersecurity and cloud cybersecurity talent in the business. We have over 25 years of recognition from third-party independent analysts, including Gartner, NSS Labs, IDC, and Forrester, including 20 times in a row a leader in Gartner's Magic Quadrant for security, and also in the cloud, Dome9, a cool vendor in cloud security, as well as we were one of the leaders of the Forrester Cloud Workload Security for 2019. And we're going to do a quick poll, if you don't mind. And hopefully this will work out okay. I don't have a lot of experiences at polls. Let's see how this goes. So the first question for our audience is, hopefully you can see the polls. What is your level of experience with the cloud? So number 1, I have no experience. Number 2, I have some experience. I know the basics. Number 3, I know a fair amount, but I'm not an expert. Number 4, I am a cloud expert, but I don't know CloudGuard IaaS very well. And number 5, I am a cloud expert and I know CloudGuard IaaS well. And I can see actually the polling is going on as we speak. So far, 55% of you that are on the webinar live, 253 people, which is quite an impressive number, have voted. I'm going to give an extra couple of seconds so that everyone else can vote. So far, we're at 73% voting. And 5 more seconds so that everybody else can vote. And I'm going to end the polling and show you the results. So you can have a look at the results in front of you. From that, I see that 44% have some experience and 40% know a fair amount, but not an expert. And so that's the majority of our polling. And we're going to have another poll a little bit later. And I would like to hand you over to Stein. Stein, please take it away.
Perfect. Thank you, Jonathan. So let me share my screen here in just 1 second. There we go. So you should hopefully be seeing my screen now with a slide titled the Virtual Cloud Network or Virtual Cloud Networking. So I'll kind of start with a brief overview, kind of based on the poll results as well. It probably doesn't hurt to kind of give you an overview of NSX, and starting with our vision. And our vision is what we call Virtual Cloud Networking. The Virtual Cloud Network is how we as VMware empower customers to connect and secure their applications wherever these applications are running. With the Virtual Cloud Network, our goal is to create a seamless network that is defined entirely in software, and that extends all the way from the edge to the data center to public clouds, as well as the enterprise branch. Now, we support multiple hypervisors. It's not just VM on ESXi as well, so multiple hypervisors, as well as various application form factors, the VMs, containers, and even bare metal workloads, which are still a reality for quite a few of our customers. And this allows us to cater to the unique networking and security requirements across this wide variety of environments. The Virtual Cloud Network is powered by NSX, and we currently have over 10,000 customers that are using Virtual Cloud Networking, including 82% of the Fortune 100 and 70% of global telcos. Then also with the VMware SD-WAN by VeloCloud, we are also a leader in the Gartner Magic Quadrant for WAN edge infrastructure. So with that, let me talk a little bit about the use cases for NSX. And I talked about the Virtual Cloud Network, which enables a single network and security policy that stretches across and abstracts hardware. Now, the automation which NSX provides allows you to spin up a workload in AWS and make that part of your environment with the same security and networking policies applied as soon as the application is deployed. And this, of course, enables a quicker time to market. Also, if you can consolidate your workloads more effectively and utilize hypervisor hardware in a more optimal way, there are significant savings to be made. Now, with NSX, customers can run workloads that belong to totally different networks, completely different zones or tenants on the same hypervisor, enabling increased usage of fewer physical servers with the obvious CapEx and OpEx benefits that come with that. Now, the last one is security. With NSX, we are delivering intrinsic security that is built right into the hypervisor as well as in the public cloud, enabling customers to achieve a zero-trust network security architecture across all applications, regardless of the form factor of these applications, VMs, bare metals, containers, and regardless of where these applications and data reside. So of course, today's talk is mostly centered around security. So let me talk a little bit here about some of the challenges with traditional security in the data center. As we all know, traditionally, data center security was really built around a network topology, which was fairly static. Applications didn't really change much, and they were typically confined to one environment. Today, however, the reality is different. As we all know, applications are being deployed across hybrid environments, leading to a lack of visibility for the infrastructure admin, who's tasked with ensuring the proper security is enforced for all the applications. Now, at the same time, automation-driven application deployment models and continuously changing applications have resulted in infrastructure and security teams having to continuously redefine networking and security configurations across various platforms and network and security solutions. And all too often, these infrastructure teams and application owners or developers don't speak the same language. Application developers typically lack proper tools to effectively determine and communicate network and security requirements for applications that they're developing, and that leads to long delays in application rollouts, and it sometimes also leads to incorrectly configured policies. And finally, network-based security policies lack awareness of the application. With applications that are continuously changing and applications that are moving across hybrid clouds, a security policy that is based on static constructs like VLANs or subnets is really inadequate, and it leads to an ever-expanding set of firewall rules even after the applications have been decommissioned a long time ago. So, all of these challenges lead to operational inefficiency as well as unmitigated risk, making the job of both the application owners and the infrastructure and security teams increasingly difficult. So with that, let me talk a little bit about our solution and the use case that we call microsegmentation. And just to briefly illustrate what microsegmentation is, let me use an analogy here of two ships. One of them is a very large traditional ship that is supposedly unsinkable. However, as you can see from the picture, one breach here in the central hull of the ship could compromise the entire vessel. And this represents an enterprise. Now, let's look at a nuclear submarine. And a nuclear submarine, on the other hand, is designed very differently. If something gets breached, the breach compartment is isolated from everything else, and the water doesn't compromise the rest of the vessel. And that's exactly what microsegmentation does for your network. It helps you to prevent a breach from laterally spreading in the environment. And so even if the majority of your workloads or user desktops may be running the latest and the greatest patch versions, the reality is that there's always a number of applications or user desktops that have not, and those often become the initial target of an attack. Without proper microsegmentation, an attack can then spread laterally and immobilize the business or obtain high value data that they're after. And as Jonathan mentioned, of course, kind of an example today is a lot of employees are, of course, working from home. And we at VMware have seen a really significant uptake in the number of customers using VDI, virtual desktop infrastructure. And we've also seen customers massively scaling up their VDI infrastructure. And while microsegmentation is mostly known for application security, for server security in the data center, another big use case for us is VDI, or virtual desktop infrastructure. And this goes from a couple of use cases, like obviously microsegmenting the actual VDI infrastructure, like the Horizon or the Citrix management components, but also additional use cases like ensuring that your different desktop pools, the pool for your contractors versus the pool for your employees, have dedicated access to the applications they should be accessing, or going even further with the identity firewall feature, which allows us to tie into Active Directory and apply a differentiated policy to your medical staff versus your financial staff, for example. That's what we call identity firewall. But an even more basic use case that is applicable to VDI is desktop isolation. And the beauty of this is that all it really takes is a single distributed firewall rule to isolate every desktop from every other desktop. So that's going to prevent things like ransomware. Obviously, WannaCry, for example, which uses Eternal Blue, it's going to prevent that from spreading from desktop to desktop. Or if you look at more recent exploits, Corona Blue uses a vulnerability or exploits a vulnerability in SMB version 3. Simply isolating every desktop from every other desktop with a single distributed firewall rule is going to prevent that lateral spread in your desktop environment. So let's talk about, or let me give you a quick example of microsegmentation. Here's basically a very high-level illustration of a basic zero trust model. With a single rule, we allow the web server of an application to talk to the middleware, to the application server, but not to the database server or any other web server. So the microsegmentation with NSX-T is completely independent of the network. It doesn't matter if you're applying microsegmentation to an existing brownfield deployment that is VLAN backed, or you're deploying a new data center and you're also using NSX to provide network virtualization. The key thing is microsegmentation is completely independent of what you're doing in the networking. So network virtualization is not a requirement for microsegmentation. Now, of course, you look at the single rule here for the web tier. We could, of course, also apply a similar rule to the apps and the database servers, only allowing them to communicate and accept communications from the workloads that they should be communicating with. So having said that, let's have a quick look at what the components are in NSX that enable microsegmentation. And there's basically on the data plane, there's 4 different components. First of all, we have our internal firewall, which is the distributed firewall, enables micro and macro segmentation. I'll talk a bit more about it in the next slide. We have our gateway firewall, which is another native component of NSX. And the gateway firewall really provides perimeter security for traffic coming into the SDDC, into the data center, as well as traffic between tenants in the data center. Then we just launched NSX-T 3.0 last week, and one of the major new features that we've released is the integrated distributed and IDS and IPS, providing threat detection for east to west traffic within the data center. And then today's topic of the conversation is vendor integration. And this is where we can layer on additional controls, such as security controls like Check Point CloudGuard, but also visibility controls, for example, integration with Gigamon, for example, to provide visibility into the environment. And that's what we call service insertion or vendor integration. So that's kind of on the data plane, what makes up microsegmentation. On top of that, of course, we have our management plane with a cluster manager in NSX-T providing resiliency as well as scale. We also support a declarative policy, which basically enables customers to define all the networking and security requirements in a single JSON file and then apply that to that application. So instead of having to make 20 different API calls to realize the networking and security configuration, you define all the configuration, all the requirements in a single policy statement and apply that to your application. Then on top of that, we have NSX Intelligence. I'll briefly cover that later as well, but that's our distributed visibility and analytics platform. And then new in the NSX-T 3.0 release is also Security Federation, which allows you to apply a consistent policy across locations. So if you have multiple data centers or you have workloads deployed in the public cloud, you can now have a single global NSX manager in which you define your policy once and then apply the policy across these multiple locations and multiple sites. So very briefly, the distributed firewall, and I'll cover this and then I'll cover NSX Intelligence for a bit as well. But our distributed firewall is a layer 7, a layer 2 to layer 7 firewall that is entirely implemented in the hypervisor kernel in order to apply the distributed firewall, which really sits at the VNIC of every workload. So it really sits at the VNIC of a VM. It also sits at the interface where a container connects into the logical switch. Key thing is it doesn't require any change to the physical networking. So it's completely independent of what you do from a network perspective. You can deploy overlay segments using NSX, or you can use your existing VLAN segments and use your traditional physical routers in this environment. This works on both physical servers as well as VMs on ESXi and KVM. So you can apply a micro-segmentation policy, not just for communication between a virtual machine and another virtual machine, but also communication from a virtual machine to container or a virtual machine to a bare metal server running Windows or Linux, or even bare metal to bare metal communication. Using NSX Intelligence, we provide complete east-west visibility and rule planning policy formulation. I'll talk a bit more about that in the next slide. And then we provide a single management plane using a global manager across all sites. So that's at a high level, the distributed firewall. A couple of really important points about that. And it is a layer 7 firewall as well, meaning that you can augment your port-based policy also with layer 7 application identity in order to further reduce the attack surface and, for example, ensure that you're only allowing TLS 1.1 and above, for example, or 1.2 into your PCI environment or into your web tiers. Then NSX Intelligence, we released that at VMworld last year. And NSX Intelligence is our distributed analytics platform, which is fully integrated into NSX. So the goal with NSX Intelligence is to provide visibility and analytics across the whole environment. And unlike traditional solutions, we don't rely on NetFlow or IPFix, or we also don't rely on a copy of the traffic to be sent to a centralized location. Instead, we use the distributed architecture that we already have. We basically use that distributed firewall that sits at the VNIC of every workload in order to send interesting flow metadata to our centralized machine learning platform. That allows us to deduplicate the flows and only send the information that is needed for us to get full visibility. So the initial goal with NSX Intelligence today is to provide that visibility as well as policy formulation. Obviously, with any zero trust solution, if you want to create a whitelisting policy, you need to understand your applications. You need to understand how the web tier of an application is communicating with the app tier and then communicating with the database. So NSX Intelligence will apply machine learning to the flows that it sees, and it can automatically propose the appropriate whitelisting microsegmentation policy. So instead of having to talk to the application owners or read up the documentation, which is often very incomplete, or manually look at firewall logs to determine what is the granular microsegmentation policy that I need, NSX Intelligence takes that complexity out of it and can formulate the policy automatically for you. So that was a brief overview of the distributed firewall and then NSX intelligence. With that, that brings me to the key topic of today, which is service insertion. And service insertion really enables customers to insert additional third-party services into the SDDC as well as the cloud. And in NSX-T, we have two ways of intercepting data in motion across the network. We have what we call north to south service insertion, which intercepts data at our perimeter. So I'll talk a bit more about that later in detail, but this is very much aligned with our own gateway firewall. So this is where we can intercept what we call north to south traffic and then redirect the traffic to a Check Point CloudGuard gateway or another appliance from our partners. We also have east to west service insertion, which is much more closely aligned with the distributed firewall. That allows us to intercept traffic at the VNIC of every workload and also redirect the traffic then to another appliance which we have deployed. So the value for this, or the main use case, is to provide visibility and security services across workloads and platforms. We provide chaining of multiple services, which you'll see in a demo today as well. And we provide either redirection or a copy of the traffic can be provided to a partner service. We provide deep integration with partners, which I'll cover in one of the next slides, and then we have flexible deployment options as well. So for those of you who are familiar with our previous NSX platform called NSX for vSphere, the main distinction between NSX for vSphere and NSX-T is that obviously NSX for vSphere really only applies to virtual machines running on the VMware ESXi hypervisor. NSX-T also applies to KVM, it also applies to public cloud, it applies to VMware Cloud on AWS, and it applies to bare metal workloads, containers, and so on. So a lot more different use cases for NSX-T. And when it comes to service insertion, the service insertion model in NSX-T is also a lot more flexible than it was in NSX for vSphere. In the sense that with NSX for vSphere, if you wanted to leverage service insertion, you had to deploy a partner service virtual machine on every single host in a cluster. This is what we call the distributed on-host model. This option is still available in NSX-T, but in NSX-T, we also have a different deployment optional model called the centralized model, which allows you to deploy whatever number of Check Point, CloudGuard appliances that you need, and then we can redirect the traffic across the overlay network to these Check Point appliances. And then, here are some of the main use cases why our customers use service insertion. A little bit more detail on east to west and north south service insertion. I mentioned the east west service insertion use case is really aligned with the distributed firewall. So we're able to intercept traffic right here at the VNIC of a workload, being a virtual machine or a container, and we can then seamlessly redirect the traffic to a partner virtual appliance. North to south service insertion is aligned with NSX gateway firewall and has similar ability to classify and redirect the traffic that passes through a logical router uplink. So what are some of the benefits of service insertion? First of all, granular service insertion, which is what I just mentioned, the ability to intercept traffic at the same granularity at the distributed firewall and the redirect the traffic to a partner in order to apply additional security or visibility controls. Simplified provisioning is we don't just insert the partner appliance into the network, but we also actually handle the deployment. So from NSX, you will basically first register the CloudGuard service with NSX, and then the service becomes available in the NSX catalog, after which you can deploy that service wherever you want in your data center. And that deployment, that provisioning is handled by NSX. Another very important benefit is ubiquitous application-based policies. That means that in NSX, when you write your policy, your microsegmentation policy using the distributed firewall, you don't use IP addresses. The vast majority of our customers use policies based on what we call dynamic security groups. And a dynamic security group means that workloads dynamically become a member of that group. For example, based on the operating system, you could create a group that groups all workloads that are running a version of Windows that is no longer supported by Microsoft, for example. Or you could create a security group based on a security tag, which can be applied to a workload at the time that it's being defined in a blueprint to identify that this workload is part of an HR management application, for example, or that this workload is a database of an application, or that this workload needs to meet PCI compliance. And as a result of a tag being applied, that workload becomes a member of a security group, and then the appropriate policy is applied. Also for server insertion, we actually share that security group with our partners. So on the Checkpoint Manager, you can leverage the same security groups on your Checkpoint policy, enabling a much more flexible policy. It also means when an application is decommissioned, the security group is automatically updated, and the IP addresses that that application was using are automatically removed from the resultant policy on the data plane, both on NSX as well as on the Checkpoint CloudGuard appliance. Flexible and scalable service chain. So, we allow customers to chain multiple services after each other, and we can also allow customers to scale up that environment. If your environment is growing, you need to deploy additional checkpoint capacity in order to deal with the increased traffic. You can easily scale up that as well. Also, if you use the on-host deployment option, we will automatically deploy a Checkpoint CloudGuard appliance on every host in a cluster as you're adding hosts to that cluster. And then because NSX-T is independent from vCenter, we can have a single policy that stretches across up to 16 vCenters per site. A little bit on the consumption workflow here. So this is how you deploy server insertion. Key thing is here, this is seamless, and this is really the same workflow across any partner service. The first thing that you'll do, you'll see that in a demo, is actually register the service with NSX, makes it available in the catalog, and this is driven from the Checkpoint Manager. Once you've done that, then you deploy the service, you apply the service, you choose what is the interesting traffic you want to redirect to CloudGuard. All of these two steps are done from NSX. And then the final step is service consumption. This is where you go back into your Checkpoint, your Checkpoint Manager, and you define the actual firewall policy from a Checkpoint perspective. And then briefly, I talked about this as well, but we support north to south and east to west server insertion. North to south server insertion was not available in NSX for vSphere, so this is entirely new in NSX. And this allows you to apply server insertion to the uplink of either a tier 0, what we call the perimeter logical router, or a tier 1, the tenant logical router, and intercept that traffic and then redirect it to a partner appliance, protecting the perimeter of DDC, tenants, Kubernetes namespaces, as well as native cloud workloads. We do have the ability to run this in the public cloud as well. And we do support active standby as well between multiple Checkpoint appliances. And then east to west server insertion, this is service insertion applied to the VNIC of a workload, a VNIC of a VM or a container. We did have this functionality available in NSX for vSphere as well, but there's a couple of differences. Obviously in NSX-T, we support containers, which weren't supported in NSX for vSphere. We have a much more dynamic service chaining support in NSX-T. We can support multiple vCenters, and then we can also load balance traffic across multiple service instances. So if you need to deploy 10 Checkpoint CloudGuards in order to deal with the amount of traffic that is being redirected, we will effectively distribute the load from these flows across the 10 instances that you have deployed. Plus, our packet delivery mechanism in NSX-T is based on a standards-based protocol called NSH, Network Service Header, and that makes it really easy for Checkpoint and other partners to complete the integration. So with that, let me talk about one more slide here, which is the support to deployment options. I talked about this briefly, but in NSX-T, we support both of these options for east to west server insertion. First of all, on the right side here is our host-based deployment. And this is where we deploy exactly one, what we call service virtual machine of a particular partner. So this would be a CloudGuard virtual appliance. We deploy exactly one on every compute node in your compute clusters. That, of course, provides the lowest latency, but this also comes at the highest cost when it comes to licensing as well as resource utilization. That's why we have a separate option as well, which is called the cluster-based deployment, in which you deploy your service virtual machines on a dedicated transport node, on a dedicated ESXi server, and then we use the network overlay in order to steer the interesting traffic and distributed traffic across the instances that you have deployed on that dedicated node. And this is what we call the centralized or cluster-based option. And with that, I'll hand it back over to Jonathan, who's gonna ask a second poll.
Okay, so let me start the polling. We don't have a lot of time, so hopefully you can see the questions. What webinar content are you interested in for the future? So it's multiple choice. You can vote more than once. Hopefully you'll only vote once for the first 3. Do you want more introductory level? Do you want more intermediate level or more expert level? And then there's do you want more VMware and less Checkpoint, more Checkpoint, less VMware? And do you want more best practices and less product specific, or more product specific and less best practices? Again, the first three are pretty much mutually exclusive. And then you can choose one of the 4 or 5 and one of 6 and 7, if that makes sense. And then I'll share the results with you. It's a little bit more complicated. I certainly hope that you're all following the instructions. And I am going to end the polling soon because we're running out of time for this webinar. Wow, a lot of voting going in. And let me show the results. So the results are, hopefully you can see that most people wanted intermediate or expert level. There were some people that wanted content, and 64% wanted more best practices and less product specific. So I'm going to have for
So since I didn't understand Jonathan any longer, hopefully my internet connection is not broken. I'm start with my presentation. Thanks to Stein for all the explanation about the NSX-T infrastructure, because it's really essential to know how NSX-T is doing the service integration to understand where the benefits comes from integrating CloudGuard on top of the values of the NSX-T security implementations. So if you're looking about the CloudGuard IaaS product suite, then we are running our regular CloudGuard, regular firewall gateway, which is the mainframe code of all the solutions that you already know for years, all on the virtualized infrastructure. The only difference between the CloudGuard and the mainframe solution based on open service and appliances is that, of course, we need to integrate with some of the hypervisor solution, as well with some specific integration parts that we need to do on the SDN area. So it's really about advanced threat prevention that is delivered by our proven technology based on our software plates. And we are integrating CloudGuard IaaS as a solution for public cloud and also for private cloud infrastructure. So you see there's a huge amount of service platforms that we can integrate CloudGuard IaaS to. And of course, we are integrating with the cloud native ways of doing that. So we supporting auto-scaling infrastructures, we supporting native constructs such as transit gateway in AWS, load balancers, scale sets, endpoints, whatever you can imagine that is provided by the different platform vendor, we can integrate with CloudGuard in such kind of scenarios. And we also offering a variety of deployment best practices. You can find them in our secure knowledge. You can go to our community platform, and you will find a lot of use case examples and best practice recommendations from Check Point, how to integrate with this kind of different platforms. If we are talking about the integration, which is the topic for today in NSX data center security, then it's the use case of microsegmentation. And as Stein already explained about what the purpose of microsegmentation is, of course, we need to consider that even if we know the protocols, if we're looking at the modern generation of attacks, then we see the attacks coming on the application layer on the payload level. So of course, if we have a zero trust model, we need to analyze in case that there's a trust between security zones, what is inside a payload. And this is what we can add as a benefit of the NSX infrastructure. And this all is done in a very automated way. So we automated the way how we deploy our instances, we automated the way how our policies are working, and we automated all the installation topics that are needed normally in the physical world. You will see it later in the demo. And everything is under the single pane of glass, our unified management, which is the gold standard in security management. Everything is controlled from a single point. It's the physical security, it's the virtual security, if it's a multi-cloud driven security, everything is controlled and visible from one unified place. If we're talking about advanced threat prevention, then we're talking about our capabilities, our software plate architecture. And beside that, we are offering firewalls, IPS, and other stuff. Of course, we are also be able to identify in a payload the content of the document that you are pushing through an open port. We are able to scan for viruses. We are able to identify communication to command and control. We can go inside the communication stream and look for documents. We can scan these documents, emulate the documents for zero-day attacks. We can extract all the content from a document that can cause an attack in your infrastructure. So everything that you know, the whole story about the Gen 5 to 6 attacks is also available inside the CloudGuard IaaS solution. And this is something that sometimes is not talked too much about, the threat intelligence that is the really brain of this kind of enforcing solution, and that's Threat Cloud. And let's give you some ideas about what we are handling and how big the threat intelligence inside Threat Cloud is. So we have 86 billion transactions per day. This means we have more than 100,000 customers worldwide that are participating in our collaborative environment. Threat Cloud, we have our own sensors, we have machine learning entities, and a lot of stuff that we are acting on a daily basis. So if there's a campaign started, we can stop it in an early place and inform all our deployed gateways about these new findings. We emulating more than 4 million files per day. So we stopped more than 7,000 zero-day files per day. So this is a very impressive number. And this is, by the way, one of the most important parts in threat prevention. It's not only about the capabilities of stopping and enforcing threat prevention technology. It's about the threat intelligence that is driven all the protections. If we are comparing our capabilities to what is the use case and giving more practical examples on what threat prevention technology can make sense and which use case, then of course, if you're looking in the north-south use case, if you're looking about the integration into the edge and the NSX-T edge, then we're talking, of course, for mainly all of the blades. If we are talking only about the east-west use case, then maybe sometimes it doesn't make sense to have a threat extraction or threat emulation. If you're looking in the VDI use case, then it makes a lot of sense. So you have the whole variety of enabling the blades per service registration that you need to protect the use case, to protect the scenario that you are like to have. If we come to this kind of SDN cloud integration, then of course everything is about automation and orchestration. And we have a long partnership with VMware. We are integrated in several solutions of VMware. And one of the solutions that we are integrated is vRealize orchestration, where you can really orchestrate the complete deployment of an application stack, which consists of the infrastructure, the applications, the virtual machines, and so on. And of course, we are integrated with some other orchestrator as well that are widely used, like Ansible or Terraform. If it comes to orchestration, if it comes to SDN, if it comes to automation, then another part is really important to understand, because there's a difference. If you're talking about security policy, there's a difference between automation and orchestration. As Stein already elaborated a little bit about what is the need of an application environment is a business-driven environment, which means that the change in the infrastructure is on demand of the application. So, of course, you can orchestrate this in the sense that the application is triggering an orchestrator that do some stuff on the infrastructure. But what is much more intelligent is to have something that automated itself, that adapt itself to the need of an application. And this is something that Stein also mentioned with the dynamic security groups. And I would go one step ahead and say that the most intelligent way of doing this, even if we support different ways, is a business-driven tagged policy. Because with text, you have a quite flexible way of adapting security policies of the need of an application. Let's give me some example. If we are integrating different platforms to each other, then we can write a policy that is aware of all the different object stores that the cloud provider are providing. So of course, we can identify a virtual machine inside dynamic security groups just based on the membership in the group, but we also can identify them as a tagged object in AWS. So you can simply, if you have a tagged policy in your environment and you use, for example, the same tags, then the application can be identified by the security policy, which runs on top of the CloudGuard IaaS, only by identifying the assets and the tags on the assets. So if something is changing, if you scale out to a public cloud, for example, the security policy is immediately aware of all the need of communication. And you can mix them up with a lot of different implementation, as we've shown in the slide before. Let's see some use cases where we can see what kind of solution makes sense in the integration in the different models. So of course, if we're talking about anti-bot is a really good use case for north-south integration on the edge. If someone is infecting one of your virtual machines with malware, then maybe a hacker can control this malware to do some nasty stuff afterwards. Thanks to the anti-bot blade, we can identify this kind of command and control connections, can stop the command and control connection, and therefore the malware is not able to download additional attack payloads. Or we also can, leveraging quarantine mechanism inside NSX-T by auto-remediation. We can inform the NSX-T manager about this infection, and the NSX-T manager is able to quarantine this machine. This is typically done, of course, between tiers or between tenants inside an infrastructure or between the really upstream links into the internet. If we are talking about IPS, this is the well-known use case for East-West. So if we have a zero trust model and we have different security zones which reflecting in multi-tier applications and also multi-levels of application. If you're looking at the modern application, it's not only about web and middleware and backend, it's also about the CRM is talking to the logistic, the front end to the customer, and so on and so on. You can imagine there's a lot of communication needed between different security zones. And therefore you need to look into the communication itself, because the payload can be the actual attack. So in this case, as a small example, this is a web application, and inside the web application, an attacker was able to integrate an SQL injection. So think about if you're checking for ports, if you're checking for protocol, if you're checking for encryption, whatever you do on the protocol layer, you will not see the SQL injection itself. You need to go to the payload, look at the SQL command, and identify the SQL injection. This can be done by service chaining inside an NSX-T infrastructure. If it's about a lot of customers asking us, and also VMware, what kind of security policy does I need to adapt on which stage? So of course there are several ways of doing that. Everything is software, everything is abstracted. It's up to you to understand the use case, the need to mitigate the risk. Therefore you need to know the risk level. There are several steps inside your organization. Maybe what's the grade of your automation? Because if you run controls on several instances, then of course you need some kind of orchestration. Otherwise, you get overloaded by administration tasks. But you can run the NSX as a microsegmentation entity and then forward the traffic to the CloudGuard. You can decide to route all the traffic to the CloudGuard because the operation of security policies is done in a different team. a much more intelligent way would be to leverage the different functionalities inside your solutions to do the best. So for example, if you drop a packet, there's no need to identify the payload of the packet. So it doesn't make sense from a resource point of view to redirect the traffic that will be blocked on a certain stage. So, and of course, maybe you have different security zones, they have different need. So you can run simple by leveraging a distributed firewall redirection policy, which kind of traffic needs to be analyzed, with which kind of threat prevention capabilities, and which can be only go to the distributed firewall, and there's enough to do a protocol, a URL, and every check that is available in the native implementation. So it's really up to you to understand what is your use case. So that's also something that is changing in the cloud area. It's more not to building an infrastructure, not to building a blueprint that is able to handle all of the application. It's really to support the business, which is driven by application. And the application should tell the infrastructure what is the need from the infrastructure, and not the other way around. Another example of combining such kind of technologies is really if you're looking into the container space. So if you're looking into the integration of PKS into NSX-T, then we are talking about Kubernetes infrastructure. And from a network security point of view, the Kubernetes infrastructure is a mess because there's a lot of NAT involved. So if you have different namespaces communicating with other namespaces, there are pods communicating with each other. They are located on nodes. So the whole concept of identifying application based on IPs will not really longer work. So you're nearly blind to the communication inside a Kubernetes cluster. And therefore, you're open for a lot of risks because the lateral movement will hit you. It's just a question of time. As the NSX-T do an abstraction layer on the network, they can simply forwarding us traffic for inspection between namespaces, between nodes, between pods, and we don't care about all the Kubernetes-specific NATs and IP scenarios. And if you want to see an example of that, this is an implementation that we did in our labs for PKS together with CloudGuard. As you can see, we're leveraging our model to integrate intelligent dynamic objects in our policy, which will be mapping the actual used IP addresses, because this is the one that we see on the inspection layer, to the namespaces, to the pods and stuff like that. If we're talking about another use case, that's VMC and NSX Cloud. We can integrate on several ways. It's depending, again, on the use cases. We can integrate and do the service chaining in your on-prem gateway. We can spin up and VPN to the on-prem, to the cloud. We can use east-west integration into NSX public cloud infrastructure. But as a use case that we build for a real customer, for example, would be that in this case, they spin up an MPLS infrastructure to all the different branches that they have, and they are leveraging the NSX public cloud. So they have a AWS VPC where they run the ESXi infrastructure driven by NSX-T, and the different tier 0, tier 1s, and everything that you were more or less aware after the webinar. And in addition, we create with CloudGuard a transit VPC that can be used, in this case, between different branches of the application. So we can separate different accounts into AWS and be the connection hub, the hub and spoke architecture for bringing connections between the spokes itself, and also connect, thanks to our IPsec capabilities, to as a backup to the on-prem network, to our Check Point appliances. We create MPLS, we create IPsec VPNs based on SD-WAN integration, also with VeloCloud if you like, into the shop systems, and everything else that is not directly connected to the MPLS can be handled in a very automatic way over this hub and spoke architecture in the connection of CloudGuard IaaS. If you like, what kind of solutions or what kind of part of our solution do you need if you want to integrate to NSX-T, then it's our CloudGuard IaaS gateway, of course. It's deployed, as Stein mentioned, in host or in service cluster mode. We have our manager, which is the smart center, or could be a multi-domain management, whatever is existing, or can be deployed as a VM, whatever is the use case, whatever the customer likes to do. And of course, we have our user interface, which is the smart console. With this, I want to give back to Stein, which gives us a short introduction how everything is working together in a short demo.
Okay, perfect. Thank you, Chris. So let me actually first answer some of the questions. We've saw a lot of really good questions came in today. I've tried to answer most of them, but just as a general trend, there were some questions around NSX evaluation. If you go to this website here, vmware.com/try-vmware.html, you'll be able to, this is not available yet for NSX, but this will be available within the next couple of days. So you'll be able to download NSX and try it out in your own lab with an evaluation license that comes with this, as well as an evaluation guide, which you can run through in order to test some, the basic setup and like the micro-segmentation use case, as well as network virtualization. Then some other questions were around scalability. So you can go to configmax.vmware.com. You can select NSX-T 3.0, and this is going to give you, you can then select network introspection. This is just another name for service insertion. And this gives you an overview of what the tested maximums are when it comes to service insertion or anything else related to NSX-T. And then finally, the VMC or VMware Compatibility Guide. If you Google that, you'll come to this website, and here you can select a version of NSX-T. You can select a particular partner, and it's going to tell you what version has been certified between Check Point, CloudGuard, and NSX-T. So with that, let me get to the demo. So quickly setting the stage in a couple of minutes that we have left is in this environment, I have deployed NSX-T, and I have two applications. There's an MRS and a medical record application, and there's an HRM and an HR management application. And there was a security mandate that all restricted applications, in my case, the MRS application, should be redirected to a Check Point CloudGuard firewall with a specific firewall and threat prevention policy applied. And that traffic should also be redirected, or a copy of the traffic should be sent to a network monitoring appliance, maybe a Gigamon appliance or NetScout. For private applications, for any data that has been labeled as private, which in my case is the HR management application, I have a different service chain, and in this case, I'm purely redirecting traffic to a CloudGuard appliance. So let's have a look at how this actually looks like in a demo. So first thing that we have to do, and this is from the Checkpoint Manager, from the CLI, we actually have to create a service definition, and we have to register CloudGuard with NSX-T so it becomes available in the catalog. I'm going to speed this up a little bit. There's a few commands that we're doing, but key thing here is we're connecting to the NSX-T manager. And then we're also telling the NSX manager where we can download the CloudGuard IaaS image, the OVF for the firewall that will then be deployed. Because as I mentioned, the actual provisioning, the actual deployment is driven from NSX. So once I've done that, the services will become available in the NSX-T catalogs. Now here we're going into NSX, go to service deployment and catalog. And now you can see here, CloudGuard IaaS was added as a service. It became available in a catalog. Next thing that we can do is actually deploy the service. So we select CloudGuard IaaS, click deploy service. We can then give it a name. We can select what type of deployment that we want to do. Do we want to do the cluster deployment, where we just deploy a particular number of instances and then redirect the traffic across the network to these centralized appliances and distribute the traffic across that number of instances that we have deployed? Or we could do a host-based deployment in which we deploy a single CloudGuard IaaS gateway on every single host in a cluster and keep the traffic locally to that host itself. So in this case, I'm going to select the cluster-based deployment. And I'm going to select which cluster do I want to deploy this on. So I select my services cluster here, specify a few other parameters, data store, and so on. The service segment here, which is what overlay segment that we're using to steer the traffic across the network. And then I choose how many appliances do I want to deploy. In this case, I selected 2. Now, as soon as we click on save, this is going to start the deployment process. So in this case, when we go to service instances, you can see that 2 Checkpoint CloudGuards here are in the process of being deployed, and these have been allocated an IP address from a pool which we had predefined as well. From here, we can go into vCenter just to verify, and you can see that vCenter is now deploying these two OVFs from the location that we had specified in the CloudGuard manager. So this is all driven from NSX, and NSX is basically going to leverage vCenter APIs in order to initiate that deployment process. This goes really fast in my demo, but then once the deployment has been completed, you can also see that we attach this overlay segment into each of the Checkpoint CloudGuard instances that we've deployed. And this overlay segment is how we will steer traffic to the Checkpoint appliance. And then we can also go to our service instances. And in this case, we can see that the deployment was successful, or two instances are both up and running. We can see the deployment status. We can also see the runtime status. We can see if any other, what the amount of traffic is that has been redirected. We also support liveness detection. So if a particular service fails, within seconds, we'll be able to detect that, and we can remove it from our pool. And then automatically, the services get added into the Checkpoint manager. So these become available right away as soon as the service VM starts up. The next thing we can do is actually add NSX-T manager into the Checkpoint manager as a connector. And this will allow us to import NSX-T security groups and use those dynamic security groups based on tag, for example, or based on operating system. We can then use those in a Checkpoint policy as well. Now that we've done that, the next step is creating a service profile. So we select our CloudGuard IaaS service, create a service profile. The redirection action here is set to punt, which means we are actually redirecting traffic through the CloudGuard, and click Save. And then, for my example, I had said that for restricted applications, we also need to redirect or send a copy of the traffic through a network monitoring appliance. So I created a service profile for that as well. And now the next step is creating a service chain. And if you looked at the example slide, I need to create two service chains here, one for my restricted applications and one for private. In case of private here, I just need to redirect traffic to CloudGuard. And in case of in case of the restricted applications, I need to first send traffic to CloudGuard, and then I need to send a copy of the packets to my network monitoring appliance, which I'm defining here. So that gives us these two service chains. I can change the ordering of this if I want to do that. So I'm moving CloudGuard to the first service in the list. Click Save. And then the final step is creating our redirection rules, in which we specify what is the interesting traffic that should be redirected to CloudGuard. You can see here I've done that for my restricted applications as well as for my private applications. These workloads here became a member of the private security group because I applied a particular private security tag to these virtual machines when they were being created. And it's the HRM application. I did the same thing for the medical record application, which has been classified as restricted. So let me take this a little bit further here. So now let me just open up my 3-tier application in order to generate some traffic. Because as soon as we do that, we are now redirecting the east to west traffic between the application tiers to CloudGuard. So I can look at my logs here. I have a firewall policy applied, which just blocks traffic between the private and the restricted zone. And we leverage the same security group constructs here. So we automatically update this to the Checkpoint manager. When you deploy a new application, we will automatically add the new IP addresses of that application into the security group and share that with Checkpoint, which is then also pushed down to the individual CloudGuard firewalls. The same thing is true if an application gets decommissioned. We remove the IP addresses. All of that happens transparently to the user. It doesn't require any user interaction. And this is then also pushed down from the Checkpoint manager to the actual CloudGuard firewalls. Once we've verified that, we can actually have a look at the logs, and then we can see that we're immediately getting our east to west traffic that is being redirected. And we can also have a look at threat prevention. We've enabled threat prevention here with a policy. And we should be able to see that we already have some IPS signatures that are firing. As you can see here, there's an east to west directory traversal attempt between our two web tier workloads that are deployed in the same VLAN. So that was a quick demo. With that, I believe Jonathan or Chris, back over to you to finish up for today.
Yeah, Chris, please take it away. And thank you, Stein. It was great.
Sorry, I wasn't aware that I was on mute. I just stopped talking. Okay.
Time flies when you're having fun.
So as a start to understand what is the benefit, so it's the most proven threat prevention technology in the market. So we are really there to prevent you from lateral spreading inside your SDDC. It's fully automated, so this is dramatically reducing the costs of operating such kind of infrastructure because it reduces the amount of manual steps inside the operation. So this will bring the security in a fraction of time and costs. And it's dynamic, it's adaptive. So as you maybe remember, the tech-driven policy as the best of class example is really leveraging real-time cloud context awareness on top of this threat prevention technology. And everything is completely managed on the best of breed solution, the market, the gold standard, the smart center technology will give you a consistent policy above all of your cloud infrastructure. To give you an idea about the next steps, you will get the content afterwards, but you can also leverage in Google and look for SK 139213, which describe all the implementation possibilities and the links to the documentation. If the best way of seeing the benefits of this kind of solution is just to try them, and there is a 15 days free of trial license attached to each and every CloudGuard instance, you can basically just deploy and service inside your NSX-T manager, and you can try out every use case that you have in mind. If you need some support, of course, you are free to contact us and we will help as much as we can. As a summary, NSX-T 2.5 is the current solution that we are integrated. It's certified on 2.5 at the moment, is built in security and supported for partner integration. As Stein mentioned, VMware released last week 3.0, and we will be certified very soon. So as you can see in the history of integration in NSX-T and also in NSX-V, we are mostly the first that support the integration in the third-party ecosystem. This shows up the real strong relationship between VMware and us. So 3.0 is just around the corner. Check Point CloudGuard IaaS integrates with NSX-T, provide you the advanced threat prevention capabilities in north-south as well as east-west, and it's really easy to use. And then back to Jonathan for the rest of the Q&A that we are not able to answer in between.
So as I said, time is I mean, life is good when you're running out of time, unfortunately. So just very quickly, for those that are interested, you can go into our website and get a free demo. You can contact us or click on that to contact us. And you can also do your own self-service security assessment. What we're going to do is we're going to take, if anybody is able to spend another few minutes, we will do some Q&A. I think I feel bad that we weren't able to do all the Q&A, and I promise that we will send all the Q&A to you afterwards along together with this recording. Just before we do the Q&A, if nobody minds, I'm going to run a very quick poll. And this is a poll that I've been asked to do by my management, and the question is, would you like to be contacted by a Check Point cloud security expert? So the answer is either yes or it's no thank you, and I'll let you send those answers for the people that are still on the call. I'll give you another couple of seconds, but in the meantime, Stein and Chris, if you want to start answering the Q&As, I think that may be a good idea, and we can take a few minutes from the people that are still on the call. Those people who are not on the that need to leave the call, I will send all of those Q&As afterwards. So Stein or Chris, would you like to take any of the questions?
Sure, I think we've gone to a lot of them, but a few one it is remaining. I see, where is the Check Point management server in this demo? Well, this is deployed in the same management VLAN where I have my NSX manager. vCenter. The key things is your checkpoint manager needs to have access to NSX manager, needs to be able to register itself. It needs to have access to vCenter as well. And it needs to have management access to the actual CloudGuard IaaS appliances that are deployed. So the CloudGuard IaaSs that are deployed through NSX for east to west server insertion will have two interfaces, one data plane interface that connects to the overlay network segments we can use to send traffic across, and then another management interface which is used for management connectivity to their manager.
Stein, I know that there were some questions to you. Would you like to explain maybe how Checkpoint deals with traffic inside Kubernetes?
I'm not sure if that's a Checkpoint specific question.
Oh, sorry, it's Chris. If Chris, you'd like to deal with that. Sorry, Stein.
There was a few questions about it. It's really depending on how your Kubernetes is integrated. So in the case of NSX-T, the abstraction layer is delivered by NSX-T. So this NSX-T can run inside the Kubernetes network. They just forward the packets based on their microsegmentation rules, the distributed firewall, and forward us the packet. For us, the only goal is to identify the namespace, the pod, or whatever you are interested to. And this is also done by the integration of the CloudGuard controller to NSX-T. So we're leveraging the security groups to identify the resources that we want to integrate with.
Yeah, the key thing also from an NSX perspective is a container is really the same as a virtual machine, right? The distributed firewall sits at the VNIC of a virtual machine, or it sits at the logical port where a container connects. So there's no difference. We don't distinguish between the two. And also, for those of you who have heard of Project Pacific, which is containers running natively on ESXi. So, server insertion as well as our native security services apply to containers as well as virtual machines in both containers running natively as well as containers running inside of a VM node.
And there was a question about documentation about Kubernetes. I think let's take that offline and we can send some details in the Q&A afterwards. There was a question about north-south traffic. For the north-south traffic, the only solution is clustered implementation. Is that correct?
So that's a good question. We didn't really go into much detail on north to south server insertion because of the interest or the time. But with north to south server insertion, there is basically two options. What we have available in 2.5 is single service insertion, in which you basically apply a single CloudGuard IaaS to a single logical router, and that logical router is indeed deployed on another ESXi transport node. So it's kind of similar to that cluster-based model. In 3.0, we are adding what we call service chaining for north to south as well. So this is where you can have a single service chain, a single set of service virtual machines, and you can redirect both traffic from east to west, from the VNIC of a VM, as well as north to south traffic through that same service chain. So that's what we call north to south service chaining. That's new in 3.0. But yes, the model is mostly similar to that clustered implementation, because you don't actually deploy, our edge node is a VM by itself. It could also be a bare metal system, but you don't actually run any checkpoint service virtual machine on the edge node itself. Instead, you would run it on a different hypervisor.
Okay, so there was a question about licensing information. Do we want to take that offline, Chris, and send that in the Q&A?
Yep, of course. So it's basically straightforward. So we use the same licensing as in our core CloudGuard solution. It's on a per core basis. So the two different packages, the NGTP and the NGTX, which is basically NGTX is adding on top the threat emulation and threat extraction. The rest is the NGTP packet will cover all the blades, and it's based on the virtual core. So we don't care about the amount of machines that you deploy. We just count the cores that actually runs on your different workloads.
That's great, thanks. And I think we'll take one last question. I don't know the answer for this, but is Cluster XL supported?
At the moment, not. We are considering to do that, but there's a lot of options inside NSX-T to cover failure scenarios. So it's really depending on what kind of requirements are from your application. So normally in this kind of virtual infrastructure, SDC-driven data centers, the application really acts differently to the legacy data center. So the real need for syncing between different nodes is not as big as before. But of course, we are still looking into also make cluster XL protocol available in NSX-T. It's really depending on the use case. And if you have the use case and the need, just let us know, because then we can change the priorities in R&D.
So we've taken up an extra 9 minutes of everybody on the call. I know that there were some people that were able to stay, and I appreciate that. I know that these are difficult times for everyone, and we thank you for joining our webinar. Special thanks to our experts, Stein at VMware and Chris at Check Point. We really appreciate the support. I think it was an excellent webinar. Please stick around afterwards. Well, not really sticking around, but we will send you the recording, the Q&A, and the slides in the next few days by email. And please look out for additional webinars that we're going to be doing together. And I can just hope that we will all manage the current situation as well as possible. And stay safe, everybody. And thank you for joining us. We appreciate it. Thanks, guys.
Yeah, thanks, everyone.
Thank you.
Thanks,
Bye-bye.
everyone. Have a nice evening.
Bye-bye.